Hi everyone, I am Saniya and in this video, we're going to continue our data exploration on the deforestation dataset, where before I talked about how we can use pandas, how we can use the pandas to help us understand deforestation, which is a very key issue, chopping down of trees, forests being destroyed, all of this, removal of forest or the stand of trees from land that is then converted to non-forest use, effects of deforestation, climate change, desertification, soil erosion. So I had another video, please see that, and I have the link in the bio, where I was talking about how you can work with pandas to help you initially understand those concepts and what is the data frame looks like and to make more sense of that. And in this video, I want to show you how you can use one of my favorite tools out there, Plotly, one of the packages in Python to help make interactive visualizations of this data and how to go about doing that and how to see the examples and then to expand on that. So let's get started. And again, I had the video, the last video kind of talking through this data set and about the poor pandas, who are going to lose their home if deforestation is not addressed. So these cute little pandas. And we're using a tool in Python, it's Python, Serpent, and we're going to use pandas, not an animal, pandas, but the tool. But we're also going to use Plotly Express here. So in the last video, I sort of talked about how we can analyze deforestation and forest loss data set, different commands, subsetting by values, sorting values, looking for values in lists, and doing all of those commands. Now here, I'm going to load it in. Now I want to visualize the data here. And this is a markdown. I want to visualize the data. But we're going to use this Plotly Express SPX as an abbreviation. So again, this is nickname. So PD is nickname for pandas, NP is nickname for NumPy. So one of the things we notice is that it says no module named Plotly. Now, this usually would stress me out a bit. All that means is that we just need to install on our computer. So all I have to do is I will go here to my Windows PowerShell or my command, if you have a Windows, and I can just do pip install Plotly. And this is sort of like downloading this package onto my computer. That's what it does. You can see how it's going to be just installing it. Pip install is just how you install package names that you do not have. We're just taking some time. So while that is downloading, what I want to show you is just Plotly and Python. The Plotly Python graphing library that we're going to use. And again, pip install package name is how you download packages that you do not have already downloaded. Because thinking of it like when you get a phone, imagine if the phone had downloaded everything. And if you don't end up using that, then it's just a waste of space on your phone. Already so much of the phone space gets taken up by applications, but we really use different applications. It really depends on us, what we want to use. So we should only have the applications that we are going to use or that we really need, I feel. So that's why some things like adding numbers or taking the length of a list, finding the number of elements in a list, for loops, all those things are standard. Finding the minimum value in a list, finding the maximum. Some things people always need to do. No matter what their application or what they're doing, they need to do. And that's fine. And you don't need to import or do anything. But other things like visualizing data, you may or may not need it. I think it's highly important to be able to visualize data, but you might not even need to do that. So if you don't need to do it, or you don't want to use Plotly Express and you want to use another platform, then you have to be able to download it onto your computer. And then when you download it, you can then import it. So I was able last time to just use NumPy as NumPy, but to get that onto my computer, I had to do pip install NumPy to download NumPy, and then pip install Pandas, just like how I did this installation here. So we can see that the installation ended up being great, successful. That's awesome. We're happy about that. So now we can, push on. Yay. Okay. It kind of looks like the Mario first, Anyways, so now let's see, now that we've gotten this, let's see if this will work. Now we're going to run this. And hey, it works. Now I'm going to load in my data frame. I'm going to run that. And I have entity, which is the country, code, year, net forest conversion. If I also wanted to hypothetically add a column that is called like dataset, I can add a new column called dataset, and then I can do something like df, and then equals, and then I can say deforestation. And this just creates a column where all values are deforestation. And then this is df. That's pretty cool, right? Deforestation and then entity. And then if I want to rename entity to something else, I can do df equals df dot rename columns equals. And then this is where I put the old column name. And then it's like a dictionary mapping it to a new column name. So the old column name that we have is entity. Not a huge fan of that. And the new column name, I want to change this to being country instead of entity. So all I have to do is I put the old column name. I'm just going to make it as a comment for reference. The old column name is entity. And then the new column name is going to be country. And like, let's say that I misspell this, or I have an extra E. Then this is renaming the columns, rename. And you can have as many as you want. Like, let's say I want to have net forest conversion data set. Like, let's say I want to also change net forest conversion. I can change this, for instance, and then change this to net forest conversion like this. And then if I do like net forest conversion, then you see that it changed net forest from lowercase f and lowercase c, which is what this was, to capital F and capital C, but entity remained the same, because if it just doesn't find it, it doesn't make the change. It only makes a change if it finds, within the old names. If it finds this entity, then it changes it to country. If not, it just doesn't. It doesn't complain either. So I just change it, and then we should hopefully see that df now changes entity to country, which is what we wanted. That is great. So that's how you can change the name. So we have country, code, year, net forest conversion, and data set. So now, here comes the big thing. I want to show you the Plotly Python library. The Plotly's Python's graphing library makes interactive publication quality graphs. Examples of how to make line plots, scatter plots, area charts, bar charts, error bars, box plots, histograms, heat maps, subplots, so many different types of plots. So let's even see how we look at a scatter plot. Scatter plot of, you have your X and Y. There's lists here. You can hover over them, see the value of 0, 0, 1, 1, 4, 4. Like, that's what this is essentially. You can hover over them. It's really nice. Or you can even have something like this for a scatter plot, where you can even see all of this. So we can just copy and paste it, the example. And actually, instead, I'm just going to call this like data df. because their examples that they give, they actually use df, and I don't want to override and cause confusion, override their variable. I want to use their examples, like df from their examples for ourselves. So I'm just going to rename this. Because you see here, this is this dim, like as we import plotly express spx. I'm just going to keep track of the link here. The reference again. So we can see this is them generating data, and Iris is a really famous data set. It has properties like sepal width, sepal length. And you can see here that, if we look at Iris, the 3 different types, Iris versicolor, Iris setosa, Iris virginica, then you can see how they're measuring like petal and sepal. This is like petal length, sepal width, petal width. They have those features, and then we can use that to help us classify these 3 types, red, blue, green. They have the 3 classes. Versicolor, setosa, virginica, 3 different types. Essentially, we have all this data, length, width, petal length, petal width, and species. We have the 3 species, and they have a bunch of this data. So this is just how we load it, and this comes built in with their package. So I often just look at their examples and see how did they get this to work. And then we can see what their data set look like. Okay, so it seems like they have sepal width and sepal length, and let's run this, make sure this works, and that we can reproduce. And indeed, we can get this. This is awesome. So what we see here is that the sepal width is here, and sepal length is the Y. They have to be the names, and the name of the data frame is there. We need the name of the data frame, and these have to match exactly. Like if you try to put this as sepal space width, something different, it would complain. It would say that value X is not the name of a column in the data frame, the DF. We expected sepal length, sepal width, petal length, petal width, species ID, but instead we got sepal width of the space. So they're really picky. You have to have the same name if you're going to go this approach. Otherwise, what you'll need to do is you'll need to have like the data frame given as a list, each column as a list that way. That's another way you can go about doing that, where we could instead have like a list and then have the plot for the list. So what we could do, and I'll show that next, but we want to make sure that sepal length and sepal width, and if we now go back and update this because of the error, now we go back and update this, now it works, which is great. So if we want to do something like this, which is what they have, if we want to, let's say, like do sepal width, as a list, we could have df sepal width as a list, because again, this is just like a list of values to make sure that X and Y have the same number of items. But this again is how you take a data frame and turn it to a list. And then we could do list, you see that this is now a list, and that's what we can put in for sepal width. And we can do the same thing for sepal length. And then, it's just the same way either way. And then we can always label them afterwards. Another thing we can do with the scatter plot is we can also like color the points. So color equals a species, because we want to color them maybe differently. We have right now what we're doing is we're focusing on the X is, the sepal width, which is here. This is our X. And our Y, in that case, is like, this is our Y here. And maybe we also want to get color by the species. So we can try this, and then we see that indeed, yes, we color by the species. So each point is now colored by the species. So this is how we can get even more information out of things. So, we now not just have sepal length and sepal width, but we also have this color by species. And then we can say title equals, and we can have a title name, scatter plot of sepal length versus sepal width for iris data set flowers. We can add this and have this nice title here this way. So that we also colored by the species. If we colored by like petal length, then it would be different. Then it seems it's like a heat map scaling, where it's like, the smaller the petal length, it's bluish, purplish, and then as it gets close to yellow, the petal length is much higher. So that's another way to add another bounce to the data set, make it come more alive. So we can see for ourselves, maybe we want to make a scatter plot, and the scatter plot could be, so the one we can do is what I often like to do is the way I go about it is I will see, okay, this is the plot here. I'm going to have the df below, df.head, this is the first few rows. The iris data set. Now I'm going to have the first few rows of our data set, the first 5 rows actually. But if you want to get more rows, like what you can do, like, and you can have like 10, and this will give you the first 10 rows. If you change, default is 5. But if you want like the first like 3 rows, for instance, you just have to change what this is. So we can do the same thing for ours too. If we don't, it automatically gives 5, but 5 is the default. As you can see here, whether I put 5 here or not, it's the same. So if I just want to read the first few, what I can say is, okay, I want to have a figure for our data set. So first things first, instead of df, which is their data, I want to put, this is our data set for deforestation, our deforestation data set. So I use this for guidance, how they did it. So I'm going to put data df here. Then for our x-axis, I want to say year. So instead of sepal width, I want it to be year. I am just going to slash out and put year. And then for the y-axis, I want it to be net forest conversion. Here, exactly spelled right. And let me just have this for now and see what happens. And indeed, what happens is that it's going to be kind of, it does print something, which is great. But it has a lot of values, and a lot of these values come from the different countries that we have. So we can see typically net forest conversion for the different countries. We can have, we can color it maybe by the country. So we can color it by country. And there's going to be a lot of countries. But now let's see what we have. Yeah, net forest conversion. Oh, sorry, I meant country. Otherwise, you can see how even still this kind of, shows the same gradient here, because if we're coloring on net forest conversion, then this is smaller to larger values, smaller to larger, smaller to larger. So yeah, that was by accident. So let's just make this country. Yeah, now we can see all the points. Like this is China, this is all these countries, Myanmar, Tanzania, Brazil, all of these. And if you just wanted to view them for just a few countries, because I think that's a lot. And I showed in the last video how we could do that by essentially having a list of countries. We had our country list. Countries of interest. And I basically did, so we have a countries of interest. Like, let me just bring the same countries from the last video here. So this is a lot of countries. It's very hard to make sense of this. Maybe we just want a few countries and we want to see the scatter plot of the few countries. And again, the title would be scatter plot of net forest conversion over time for various countries around the world. This might be. So that's how this can look here, but there are lots of countries. So what we talked about in the last video was sort of having a mini data frame, like reducing it. So it's basically, we have this countries of interest, it's a few countries here. And what we can do is we can just kind of reduce this data df country, because now I changed it from entity to country. Country is in this list, countries of interest. I can call it list as well to make it easy to remember, list. If it's in this list, again, I talked about this more in the last video, but we can sort of reduce mini df to be just rows for the countries in our select list. You know, Argentina, India, Brazil, Thailand, US, and the world. The world isn't in a country, but it's a nice reference. So now instead of doing this, we can just plot, instead of data df, we can just plot our mini df here. And then year, country, scatterplot, net forest conversion for select countries. And now this is a little bit easier to see. And this shows the world and the Brazil and Argentina, Thailand, US, and over time. And this data set just had 4 time points, 1990, 2000, 2010, and 2015. We have this data captured for them. So that's also really cool. That shows you how we can take our scatter plot and work with that information. If we wanted to make a line chart, then the idea is similar as well. I just went back on Plotly and I said, hey, I want to make a line chart. We finished Scatterplots, and they have more examples of how you can get sophisticated with Scatterplots as well. You can even make the sizes change as well. They have a size variable, size, and you can choose if you wanted the size to be based on petal length. You can color on species. And when you hover it, it gives you information, you know, petal width and stuff. So we could also do that too, actually. We can also look at line charts. So what you'll notice is because we've imported Plotly Express with the nickname of px, to make the plots, it's like px.line. Like the scatter plot is just px.scatter, which is Plotly Express. So that's where that nickname kind of pays off a bit. So we can look at how they made line plots as well, and we can see some examples. So we find something that we really like. This has multiple. Okay, let's look at this one. And this is just them preparing the data so that they can show you an example. So, and they use df, that's why I rewrote ours to data df. So let's see their example. So how did they plot this line plot? So they can keep changing their data as needed, but I just want to show you how we can adapt. And we can just take this URL here and paste it here for reference. And okay, this is df. And they're looking for continent Oceania. And they have country, Australia, New Zealand. So this is a stack. This is a long data frame. So there are 2 types of data frames. There's a long data frame and there's a wide data frame. And what I think is better, especially for Plotly, is the long data frame. So it's long, it's kind of tall. And the wide just kind of lists it, but has them as, rows and then additional columns. And then like, let's say we want to plot South Korea, China, Canada, the different nations here. And then we want to see gold, silver, bronze, so just do some sort of operations. The wide makes it a bit more challenging to do that. But it can be done, but I feel that it's much easier though to work with the long data frame versus this is the wide. The long is much easier to work with, especially in Plotly. And you keep the same information preserved, like this South Korea gold 24. This information is pretty much what the information is here. Except you're preserving it. South Korea gold 24, South Korea 24 gold, South Korea silver 13, South Korea 11 bronze. That's what you have. South Korea silver 13, South Korea bronze 11. Same information, you're just reshaping it here. So it's nice and tall, but this one is often more preferred the way to work with it. You don't lose any data. We've created another column that has metal that captures this information. And this one is easier to work with. So I would recommend the long DF. It's easier to work with in Plotly. So if you can restructure the data frame so it looks something like this, then that's great. You have to create a column like, so to preserve the information, and another one called count. But this is kind of more challenging. You might have to add traces or get into all of those things to get this to work here. But this one is kind of easier to work with. And this is actually the form that we're looking at with Oceana for the line charts as well in Plotly. So it's actually the form of a long data frame. And this is a wide. And there are various ways you could do that in Python, and I could talk about in other videos. But luckily, we already have our data as a long data frame. It's already of this type of format where we have like country, and then we want, South Korea, China, we have some information as well. I mean, this is what they've given, country, and then they want to look at some metric, like life expectancy of the country. So then what they do is they just plot it, and we can see the country and life expectancy. And luckily, similarly for us in our data DF, we have all the countries kind of stacked out for all the years stacked out, and we have the net forest conversion. So it's similar to this. We have redundancies. We have some, in terms of the country, Algeria, and then we list out the values of the different years. That's exactly how we do this with this long data from South Korea, then South Korea again, then South Korea again. But this time gold, silver, bronze. This time Algeria 1990, Algeria 2000, Algeria 2010, Algeria 2015. And similar for them, they also have the same Australia 1952, Australia 1957, Australia 1962. Then they have the same for like New Zealand, different years. And that's how they show this. So for us, we're going to see, okay, how did they do this? Okay, they had these. We want to, instead of year, lowercase, ours is capital year. And ours is data DF. But again, for the line plot, maybe let's just keep it to a few countries. So let's just use the mini DF that we have, because we don't want to show for all the countries. It might be very cluttered. Let's just keep it like this. And I'm just going to have the head. Let's just show the first 5. So we have this mini DF. It's the same thing, but it's just those countries we wanted. Year, and our Y is our net forest conversion. And then color is country and capitals, because that's country and capitals. So let's run it. And what we observe is, yep, it looks something like this. And just in case, you might get something really crazy. And I think before we do this, it's always a good idea to make sure that your year is sorted before you do something like this. Because what happens is the line kind of connects. The line plot is like connect the dots. Like if you have like, if there's something and you're trying, it's just going to try to connect the dots. Like it's going to like, it might just be all over the place. So it's important for you to make sure that whatever you're having, like year, it's sorted as you want it to be sorted. So it's always good. And we talked in the last video again about how to sort the mini DF equals mini DF dot sort values by equals year. And we just want to make sure, it could be sorted, but we just want to make sure it's sorted, because what if it isn't sorted? Because like, let's say that I sorted it by year, for instance. I just want to show you like what I mean. Well, let's say I want to sort it by like net forest conversion, just something. I'm just going to randomly just mess it up a bit. And maybe let's see if it comes out badly. Yeah, so this is what I meant. So this, if the same data frame, if I just ended up changing the order a bit, what we see is that I just sorted it by net forest conversion here, just to randomly mess it up right now. And you can see that it's sort of the years are not in the right order. Like for Aruba, we go from 2015 to 2000 to 1990 to 2010. And if we look at Aruba, for instance, it's all over the place. So let's even look at Brazil. Brazil is 1990, 2000, 2015, and 2010. So its order is kind of messed up for Brazil. And then for Brazil, when we're looking at, this is for Brazil, you click it and it disappears. Brazil, it's here, here, and then going back. Because indeed we had it 1990, 2000, 2015, then back to 2010. So it's going here, going up to 2015, then coming back to 2010. So it's super important for you to sort them because it's connect the dots. So I'm just going to go back and just sort it again by year, actually. I'm just going to make it back to normal. And then I'm going to plot it. And that it looks great now. It looks great. Awesome. And then the title is just line plot of forest and net forest conversion for select countries over time, 1990 to 2015. So that's how you can do that. And then there's another type that I want to show you, which is called a bubble map. And that's super cool, especially if you're given this type of data that is, geographic data. It is a really cool type of plot. And we're going to see again how we can do that using, Plotly's, not line charts, but they have really cool functionalities. They have all these heat maps. You can really get filled area on maps, density, bubble maps. We're going to use a bubble map for now. And we can have something like this, where the size is just the number of, data points inside it, or we can even have an animation where we can see over the years, you can see how the bubble sizes are changing. Wow. So I'm going to just take this again, as we were doing before. And we already have the Plotly imported, but I'm just going to have the URL for this. And this is how it's helpful to look at a reference and see how they're working with it, so that when we use it, it'll make more sense for us too. So we have this here, it's put cell, and then we have DF. So now we can see again that they have all the countries and the continents that they have the information on. They have the year, they have the ISO alpha as well. They have a lot of information here. So when they plot this, it works for them, yay. And you might be wondering, so to get the locations, they use this ISO alpha, which is a 3-letter code, which we fortunately also have for ourselves. We typically, except for the world, we have the code here. India, IND, Thailand, THA. They have the code. If we were to change ISO alpha to country, this would not work. Nothing would map. It's really important to use ISO alpha code, the 3-digit code. This ISO alpha code is what they're using. The color is the continent. So we have Asia, Europe, Africa, Americas, and Oceania. And what the size of it is given by the population. So the bigger the size, the more the bubble size would be. And they're showing the year is what they're using for the animation frame. So what you'll notice in the plot that does not have animation, what they did is they just sort of kept the year at 2007. And again, with Plotly, you can zoom out, you can, view the home. You can take a picture, I took a picture of this plot, and now it's sort of saved on my computer like this. You can take a picture, a little camera here. You can zoom out as well, which is pretty cool. You can reset it. You can keep zooming in. You can, move around. You can zoom out. You can reset it. You could even do a little Texan cowboy lasso selector. Hey, I want to zoom in here. And maybe I want to just download that or something. You could do some advanced things too. But you see here that there was no animation frame over here, nothing. The difference is that we have animation frame here, and we use the same data here, px.data.gapline, but these come preloaded with this package. But instead we focused on year 2007, we kept the year constant. But here, another way to have done this would have been to do, like we could have done df equals, px.data.gapminder. This is the approach I typically use. And then the next line would have been df equals df year equals 2007. That's another way you can do it if you like my approach as well. So that's year equals 2007. You can just query it directly and override it. But they did it in one stroke like this. Just get the data and find 2007. That's how they did that. But of course, what you could always do is just do it, where you can, but here, because we're having all the years, we're not, restricting it to any year. And instead we have 2007, but all these other years here too. And we can see how the bubble map changes over time. So again, we can just rerun. This is pretty cool. It's a nice little frame. It's cool. So we can similarly do something like that for this. So for this is their DF, and that's how they did it. But we want to probably, now it's a map, so we can probably just use our data DF directly, with all the countries that we have information on. And what we could do is just kind of use the same idea. So the size, we don't have population, we have net forest conversion instead. Oh, I'll just do it, net forest conversion. And then year, our year is capital. And this part you can just keep, the natural earth is what, this is default. So just showing the natural earth here. And I'm sure you can change it as needed. And when you hover over their plot, they give you the country, Bangladesh, China, Afghanistan, Finland, Iceland. They give you the name. They don't really focus as much on the 3 digits. So when we hover over it, we also just want the country. And the color, maybe we want the color to just be, the net forest conversion. Or maybe we don't even want the color. It all depends. We can color it on net forest conversion as well. And the DF always is data DF, not DF. Because if we try this, it's going to complain. Hey, I don't see these columns. Net forest conversion, it's looking at DF, and that's not what we have. Oh, and one more thing is, we don't have ISO alpha for the 3-digit country code. Ours is just called code here. That is because it would say, hey, locations is not the same, we received ISO alpha, but we expected one of these. So now we can see. Okay, it has some really small values. So we can just kind of do some filtering. I think that this is giving some difficulty. So let's just filter it by positive. Let's just look at positive net conversion. Just for the sake of this, if you get some error, I just kind of want to show you it working right now. But we can just filter this to just being greater than 0. Because I think it's getting really small values and it's kind of troublesome. Greater than 0. I'm just going to say positive, greater than and then we can just see that. Whereas data df shape at 475 rows, this is probably going to be a lot smaller, 171 rows, but we can just still use it and just kind of plot this. Okay, great. So now we can see how it's kind of working, where we have like the US and a few countries as well, like Hungary, Uzbekistan, and we can see over time how this is changing. That's pretty cool. We can have like a bubble map. If we wanted to get the continent information, we would have to do something called a merge, where essentially you just have to kind of join we have the positive this here, and then we also have their data frame. Their data frame, we can focus on like country and continent. and ISO alpha. And then we have this. There's some duplicates, so we can just do drop duplicates. And you see that instead of having like multiple rows for this, because these multiple rows correspond to how they have other columns, like, you know, they have year and life expectancy, you know, they have the different years. So we're just dropping this. The drop duplicates has to have this. So now unique ones like this. And we can just make this like mapping df is something like this. And then I want to kind of call this, it has to have a common name, and always we call it code. So I want to kind of also I want to have another column that I'm adding that is just called code. And I just want it to be the same thing as ISO alpha. So this just creates duplicate column of ISO alpha and renames it and with name code. I could do it this way, or this is one way I can have a duplicate column, or another way I could just do it is I can just say that we talked about renaming mapping df equals mapping df dot rename, and then columns equals, and then I want the ISO alpha. So let's say that I just reset everything and I have just these. Okay, so now I'm gonna just, this is another way to just rename it. I want to rename ISO alpha to being code. So it's great. Now we have a common column, which is great. And I want to show you guys something that is a little bit involved, something that I sometimes find a little bit tough. And it's called merging, actually. How do you merge data frames? And that's what I wanted to show you, how we can merge data frames here. And what we can see here is if we have merge, oh gosh, merge. So if we have a data frame and they have a common column of any capacity, like let's say that they are sharing anything in common, we can join them. Like if these data frame left and then data frame right, they have in common, they have this column called key and key. So when we merge them together on this column, so this is the left data frame and then this is the right data frame. If we merge them on key 0, key 0, 1, 2, 3, key 0, key 1, key 2, key 3, it'll match them together in this final result data frame. That's what it's going to do. And then for this result data frame, it'll be right here. And we'll see that we have the key and we have our A and B from this left here, and then the respective C and D. And it depends how you do the joins. But right now, I'll just do a join on everything here. So I'm going to just take this idea of merging like combining them together. And I'm going to say that they both have code in common. So I'm just going to call it result. The left one I want to have is positive net conversion df for my left. And my right is going to be mapping df. And what I want to join them on, they have the common code. That's what's common between them. Again, what's common between these is this common column of code. The orders may be different, but it's going to find the matches and then combine them. So we can see indeed that we have the country, the code, the year, net forest conversion, deforestation. This was our old data that we had. This was the old from positive net conversion. And now we also added in information on the continent as well. You can see again the countries match as well, but you know, because whatever we have from here joins the other. The continent, now we have information on the continent, and we can actually sort of use that here now. We can color, instead of net forest conversion, we can kind of just decide to color it based on the continent. So instead, we're going to just plot like the result here. We could have the same thing as before, or we can just choose to color based on the continent, because we're already doing size based on the continent. So we can just do this. And indeed, we have Africa, Europe, Asia, and Americas here, the different colors. And we can see over the 4 years. And then we have to also see how we can change this around. But that's a little another beast though. But I just hope that this helped you kind of see how you can make some visuals of the data in Python. So we talked about how we can do scatter plots, line plots, bubble maps, and there's just so much. So I really hope that this helped you. So if this helped you, please let me know. Please like and please subscribe to my channel. Please ask me any questions that you have. Please tell me how your visuals came out. And I'm always happy to help. And I'm Saniya, and I hope that you found this to be very helpful. Thank you guys so much.